We're going to keep going with our review of simplifying and radicals. In this case, we're going to be talking about how we multiply and divide square roots. Multiply and divide square roots. So quick question here, what is a product? Most people think a product is an answer to a multiplication problem. That is, but you can also say a product is the multiplication problem itself. So I'm just going to write down that it has to do with multiplication. So whenever we see a product or the word product, we know we've got multiplication in there somewhere. Same with quotient. A lot of people think it's just the answer to a division problem, but it just means it has something to do with division. And then when we simplify square roots, what we're looking for is pairs of factors. Pairs of factors, all right? So there's some really nice properties that we can use when we're talking about multiplying and dividing radicals. So let's take a look at the product property. The product property works like this. If we're taking the square root of a product, what we can do is we've got one big square root and then we've got the product underneath. What the product property allows us to do is say, hey, look, I can take the square root of the first factor and I can multiply it by the square root of the second factor. So it might be more convenient to write it that way sometimes. And then the quotient property works in the same type of way. If we have the square root of a quotient, we can write the square root of the top and put it over the square root of the bottom. Now, the important thing about this is we can actually use these in both directions. We can use these forward and backwards. So what we can do here is we can write a product or a quotient underneath one radical. So if it's more advantageous to write it like this, we're going to go ahead and write it underneath one radical, okay? Or we can write it under two radicals. So if we want to write it as two separate radicals and then multiply them together, or write it as two separate radicals and divide them, whichever way is more convenient for us, that's what we're going to do when we're simplifying these. Now, there may be some times down the road where you wouldn't want to simplify first. You wouldn't want to break them apart or something like that, but you can deal with those when you get there. So we're going to simplify using the product property of radicals. And again, we're going to assume that all of the variables represent positive numbers. So on A, we don't have any variables on this one. So here's the advantage. What we have here is we have a radical that can't be simplified, multiplied with another radical that can't be simplified. This is just a 7. This is a 3 and a 7. We don't have any pairs. So it's written like this, but if we go backwards, if we write it like this, underneath one single radical, this is going to be 7, and please resist the urge to multiply these together. Don't multiply these together and get 147. You're just going to have to factor anyway. So I'm going to leave the 7 right there, and then I'm going to write this one as 7 times 3. So there's our pair of 7s. And we get 7 radical 3. So what happened is we went from a problem that could not be simplified with either factor, but when we put them together, then we can simplify. So let's take a look at the next one. We can do some simplification here, but let's take a look. I'm going to go ahead and write this as a 2 and an x and an x, and then this is a 2 and a 2 and a 2 and a y and a y and a y. Now, if you want to simplify a little bit differently than this, the interesting thing is the more complicated the math gets, the more ways there might be to do a problem. So I'm going to show all this out. So we've got a pair of x's, which we could have seen right here in this case. We've got a pair of y's, which we could have seen right here also. Okay, so that's going to be y. And then I've got two 2's right there. So I've got a pair of 2's, and then I've also got another pair of 2's right there. So I have two pairs of 2's, so that's going to be a 4. Now let's take a look at what's stuck underneath. Well, we took out all the 2's, we took out all the x's, and we're left with a y. So this right here is all that's left. And if you took a look at that, we could actually say, hey, wait a minute. This would have been 16, and then x squared y to the third. There's our 4, because that would have been a pair. There's a pair of x's, so there'd be one on the outside. And if you've got 3 y's, you've got a pair of y's that you can take out with one left underneath. So lots of different ways to think about that. So let's go ahead and do this one right here. I'm going to write the -8 for the coefficient, and then I'm going to go ahead and write it this way. I'm going to write 3 times 5 for the 15. I'm going to write that other 5 over here. Now, again, we've already taken these 2 and the 2 and the -2 and the 4 and put those out front. So I've got the numbers taken care of. I've got those coefficients taken care of, and then I've got 3 A's. 1 from this one, and then 2 from that one right there. So pair of 5's, pair of A's. So that's going to be a 5A on the outside. So we're going to have -40A, and what's stuck underneath is a 3A. All right, so there's the answer on that one. And then here, again, we've got 2 separate radicals. Let's write it underneath one of them. Now, this would be a 2 and a 3, and that's a 5. We don't have any pairs of numbers, so we're just going to write that as a 30. And then we've got an x and a y, no pairs there. So this one, really the way we simplify it is just by writing it underneath one radical. Okay, so let's come down here and let's talk about how we can apply the quotient property of radicals. So we'll take a look at this one. This one's example 4. So it says, simplify using the quotient property of radicals, and if possible, do the problem in more than one way. So let me show you what I mean by that. So on this problem here, let's take this and let's break this up into the square root of 9 over the square root of 36. Remember, it's written underneath one single radical. We can break it into the radical of the top over the radical of the bottom. So this ends up being a 3 on the top, and we end up with square root of 36 on the bottom. That's a 6. And we end up with, let's see, I can reduce that fraction, so I end up with 1/2. So 1/2 is the answer to that one, but let's see if we can do it a different way. So what would happen if we were to take this and say, hey, wait a minute, I can actually reduce this fraction right here. So 9 goes in here once, 9 goes in here 4 times, so this would be 1/4. Then I can take it, now I can break it into a fraction with a radical on the top and a radical on the bottom. Whoops, thinking ahead here. Square root of 4. Square root of 1 is 1. Square root of 4 is 2. And we end up with the same answer either way. So we're in good shape there. Now let's take a look at the next one. On this, if you wanted to simplify the top and bottom separately and then do the division, that would be totally okay. So we'll do that in just a second. Another way to do this would be to do this. Let's write it underneath one single radical. Again, we're using that that quotient property of radicals in reverse. So I'm going to write 6x to the 4th over 3x squared. I'm going to cancel these two with 2 of those. I'm going to cancel this with this. So what I end up with here is a 2 and x squared. And I can take out the x because that's a pair of x's. So I'm going to write x radical 2. Okay, a little weird to have the number on the inside and the variable on the outside, so that's a little bit strange. Let's pull this up and let's do this differently. I'm going to simplify this. I've got a pair of x's, 2 pairs of x's here actually. So I'm going to write x squared on the outside, and then I've got a radical 6. And then I've got 1 pair of x's here, so I'm going to write x, and then I'm going to write radical 3. That's a radical 3. I can cancel this x with that x. So what I end up with is x, and then I've got radical 6 over radical 3. But remember, let's write this as one single radical. This would be radical 6 over 3. Those cancel to be a 2, so we end up with x radical 2 either way. Okay, so lots of different ways to do this. You don't have to do it in more than one way, but it is kind of interesting if you try that. So let's take a look at the next one. I'm going to go ahead and simplify this one. Let's do this one using this technique that we did right here. So I've got 5 x's. That's going to be, let's see, that's 2 pairs of x's. So this is going to be x squared and radical 10 with an x there, okay, because there were 5 of them, so there's 1 left over on the inside. I've got a pair of y's, and this is 3 2's, so I've got a pair of 2's and 1 stuck underneath, okay. So we have, let's see, we have x squared, 2y, nothing to simplify there, but watch what happens if I do this. Then I have 10x over 2 underneath the radical if I write it as one single radical. And then I can cancel this and I end up with a 5x. So radical 5x. And notice that the 10 is kind of in the numerator, so that's where this radical ends up. So we end up with an x squared and then a 2y right here. Okay, so there's the answer, but there is more than one way to do this. So the other way to do this would be, let's write it underneath one big radical, and watch what happens here. So I end up with, 10. So I'll have 10 x to the 5th. Need to get my game together here. 8 y to the 2nd. Let's reduce this just a little bit. So what I can do here is I can do a 4 and I can do a 5. So we've got the square root of 5x to the 5th over 4y squared. So let's see what we've got. Square root of 5x to the 5th, square root of 4y squared. That's going to be, gosh, pair of 2's and a pair of y's. So this is going to be 2y here. And then we've got 5 x's, so that's going to be 2 pairs of x's. So that's going to be an x squared here. We're left with a 5. That's going to be stuck underneath, no doubt. And then we had 1 extra x right there. So again, same answer either way. Now let's take a look at the last one. Definitely an easy way to do this one, at least as far as simplifying what's inside there. I'm going to go ahead and zoom in on this one. just give ourselves some space here. We've got a fraction for an exponent. So this is what we're going to do. I'm going to go ahead and cancel this off. I've got a 49 and a 98. That goes in there twice. 49 goes into 49 once, 49 goes into 98 twice. I've got 5 A's on the bottom, and I've got, let's see, 11 A's on the top. So those 5 are going to cancel with 5 of those. That's going to leave 6 of them. So what we have here is we have 5 halves, and then we have the square root of, well, everything canceled from the denominator, so the only thing left in the numerator is a 2 and an a to the 6th. Okay, so let's think of it as this stuff over 1, and then let's simplify this radical. So this is going to be a 5, and then we've got 3 pairs of a's. If you've got 6 a's, you've got 3 pairs. So that's going to be a to the 3rd. The 2 is stuck underneath, and then notice there's really nothing that we can do with the bottom, so this is just 2 times 2. Now, I'm going to circle this, but let's talk about what a lot of people look at, and they say, hey, wait a minute, can't I cancel this 2 with that 2? Well, you can't. Okay, because this is not really a 2, it's the square root of 2. If you throw that into your calculator, you're going to get about 1.41. So you can't cancel a 2 outside a radical with a 2 inside the radical, because that's not really a 2, it's a radical 2, a square root of 2. So keep that in mind as you're going through and doing these. These are really good problems to review and get used to. We've talked about these before, but again, excellent skills here. Go ahead and do the self-assessment, and then good luck on the assignment.